Yo, what up? Is this thing on? Hello, hello? I think it's working. I don't know, we'll find out. A calculator. I don't know. It's kind of cool. I think it's got vibes. It's also got a bunch of tubes. A bunch of numerical vacuum tubes in there. There we go. Originally I wanted to get a handful of these tubes just to play around with. And they're kind of expensive if you get like like 4 of them for $20 something or whatever. But I also found this calculator which has them, and now I just want the calculator to work, so first things first, this battery case is super mangy. Yeah, and it looks like somebody already got into this thing. So I'll probably need to take this apart at some point. But I want to get into this because this thing takes 6 volts. And I tried powering it with the benchtop power supply, and it didn't do anything, so and I need to get under this. I could try to like spare it, but I don't know. Try like a little isopropyl alcohol might do the trick. I don't think I'm really worried about the warranty on it. Whoop! Making a mess already. Okay, guess it wasn't that bad. This thing's supposed to be pretty serviceable. I'm not too sure though. Serviceable for an idiot like me? Who knows? They can't even get it open. Oh, we just got some really gnarly plastic clips. Oh. Rip. Rip Spudger. Bruh. Easy to service, huh? I'm missing another screw somewhere, am I? I hope not. Does it slide? It's like a sliding mechanism? No? Oh, listen to these buttons. Alright. Alright, how do we open this sucker? I think it just uses crazy plastic clips. Oh my goodness. Alright, let me get my other spudgers. Alright, one of these is sure to get it open, right? Jeez. No? What a solid calculator. Perfect seam. Wow, really? Okay. gonna cut myself with plastic tools. What's gonna happen? Okay. I think we got some clippage going. Oh, there we go. There we go. Hopefully I didn't break anything. Okay. Sheesh. Stick all this shit up here. For those of you that come after, there are plastic clips here and here. Alright, let's take a look at this sucker. Look at that, that is crazy. But I want to get this thing working. I have no idea what's wrong with it, but I figure we can take it apart and try to figure it out. It looks like we can just take this whole module out. Yep. That's cool. There they are. Look, you can see where they even capped off the vacuum tubes. I hope none of these are actually like burnt out or damaged, but we'll see. Really nice buttons. They're actually, wow, that's pretty crazy. They're reed switches with little magnets that pass by them. If I can get a photo or shot of that. So this is the button on kind of like a little carrier. And right behind that, down here, behind this board, kind of hard to see, but there's a little tube with a reed switch in it. Like right there. Yeah, you see that glint? That's the glass tube with a reed switch in it. And so these pass by a reed switch, and that's kind of what activates the buttons. That's really, really cool. Alright, let's write down the chip for this. TMS0115NC. Let's see if we can get a data sheet on this thing. I mean, it's an old chip made by Texas Instruments. Calc chip. Let's see. Wonder if they've got a thing for it. Alright, robot. TMS0100 family of calculator chips. Ooh, Ken Sheriff. What you got? A bunch of stuff that I am not familiar with. Something to read for later. Okay, well, we may not need that, but see if we can see any immediate signs of damage. Might be like a capacitor, probably, if anything. Ooh, this comes out too? Nice. At least it looks like it does. Ooh! Sheesh! Yeah, that's actually very serviceable. I appreciate that. I don't see anything immediately concerning in terms of like damaged stuff. Our fuse is still intact. Got a fuse right here that still looks good. Let me grab my multimeter. Alright, we're gonna start with this thing. You know, I'm not entirely sure. This integrated circuit is huge though. Some flux. This board's got a lot of flux all over it. Maybe these capacitors are bad. They look good, honestly. But you'd think like a piece of hardware from the 70s would have some bad capacitors on it, right? There's kind of some silk screening on the board too, which is fun. It's less silk screening and more like writing done with solder. Alright, well, let me, just for starters, let me put it back together. I mean, that looks pretty grody over here. I don't know what that's all about. Let me put it back together and just test and see if maybe it was dirty contacts. Because there are some contacts in here that are pretty old. I mean, they look good, but we'll see. There we go. And then this is positive, so that's positive over here. We test the continuity to this negative. Goes over there. Continuity to this positive. Oops. Guess none of these positives go over there, huh? Bruh. Get out of here. Alright, well, regardless, we know this one is negative, so that means this one is positive. So battery goes in there, positive on that side. Let's go ahead and get 6 volts on the power supply. Alright, good enough. Got nothing. Okay. I see a VC, what is that, VCG? Voltage ground. Right, so we're getting 5.6 volts over there. 5.5 over here. I don't know what these circuits are for, but what about if I probe these? So this is a ground coming from here, running all the way over here. This is all ground as well. Well, there's definitely power running through the board, right? Oh, this trace looks kind of gnarly. I don't know. Dude, these sleeves on these clips are so slippery. It's the worst. Doesn't help that this clip is bent. Yeah, I still don't see anything overtly wrong with it. So I've got a G next to this, which I'm guessing is ground. That's kind of what this seemed like. There's one pin. Where is it? This one? Right here. It goes between all of these. And then there's another pin right here. that goes between all of these. Other than the other pins, this seems fine. I can't really test these because I can't see the circuit. That's probably not the issue. No, I don't want to damage the power switch. Use my broken spudger? No. I want to see what the other side of this looks like, but yeah, it's okay. Rather not damage the power button. What a chunky power button. Got a little ball bearing in there. Okay, so the positive and negative are these bottom two pins right here. That would be these two right here. Be nice if I had a pinout for this chip. That would be ideal. The chip integrates 3,520 bits of read-only program memory, 182-bit serial access memory, and a decimal arithmetic logic unit. It has control, timing, and output decoders, but no drivers for the display. Oh, here we go. Is this what I need? This should be it, the TMS0115NC. Let's check. So we've got voltage ground at the bottom right over here. Voltage source up here at the top right. So we can check those. Check those and verify if those are accurate or not. Alright, so DSS should be this pin right here, that one. And that should be coming straight from, well, not straight from, but as close to. It's nice because this board is only like 2 layers front and back. you can actually see right through it. I don't have a flashlight, although I'd be able to show you. This is our VSS pin. Let's go ahead and test this one. Top right? No. Okay, so is this chip not getting voltage from somewhere? Let's test the ground. Right over here. Oh. Let's see if I get anything off of this thing. Any continuity? Okay. Right there to that resistor. I know it's not a microscope, but it will have to do. So this pin right here is our ground. This is our VGG over here. VSS we have right here. Yep, VSS. So that's all connected, but we don't get continuity between our positive pin on the battery, nor do we get it on the negative pin of the battery over here. So maybe there's somewhere between these voltage planes and ground planes, or buses, or whatever you want to call them, where it's not doing what it's supposed to be doing. This is a crazy looking part. Look at this thing. What the hell is that? I don't know. I can only assume it's a resistor, right? What is this? Look at this. That's just a piece of wire. Look at that sucker. Huh. Whack. Okay. We also have a clock input. Oh, negative voltage VDD. Negative voltage VGG. So we've got another pin on here that we can test to negative voltage. So this is VGG. Where's VDD? VDD, they probably share. All kind of the same thing. So if this one is our ground over here, VGG, this one is also supposed to make continuity with the ground, which it does not. That might be problematic. So this looks like to be our power input, kind of filtering stuff. Let's see how this works. I wish I knew more about circuits. You know, I bet you these capacitors are bad. It looks like on the bottom they may have, they may be a little bulgy. So right down here, they look a little bulgy. Maybe we can try replacing those. That might be a good first start. Replacing the caps. Usually with older stuff, that's probably what you want to do. So first off, let's try to match some parts. But I don't know if we've got what we need. It's kind of generic Amazon shit, you know? Alright, so first off, 10 volt, 100. So we don't have a 10 volt 100 farad. That's kind of annoying. What about a 33 microfarad 16 volt? There we go. 3316, okay. How many of those do we have? I think it's just that one. About a 1 farad. 50 volt 1 farad. I think the ones that we're missing so far. Whoop, whoop, whoop. They're rolling. They're rolly boys. Bruh. For real. Okay, just to double check, this is our mystery cap. 116, 100 microfarad, or 100, yeah, 100 microfarad and 16 volts. So that's this guy right here. And then we've got a 1 microfarad 50. We have 2 of those. 1 microfarad 50, that's going to be these 2 guys right here. And then we've got our 3316, which is right here. I think at this point, I just need that 10, whatever that is. Could be wrong on this, but I believe you can use the same, as long as the capacitance matches and the voltage is higher than the rated voltage. If anybody knows, tell me, otherwise I'm gonna keep looking it up. What are the actual factors? Is this a real website? Higher voltage rating will be okay. Tighter tolerance of capacitance value is okay. Higher ripple current is okay. Higher temperature rating is okay. Remain the same nominal capacitance. Yeah, I'm pretty sure the voltage can be fine, or the voltage can change, as long as it's not lower. Now let's just find a matching 10 volt 33 picofarads or microfarads, whatever. Okay, 1633. We already have one of those. And that is a 10 volt 100. So we could do this 16100. That seems better. 100 and a 16. we've got this one to that one. These two go to these two. This 116 goes to this one, which is, no, it goes to this one, which is 110. Okay, so that's the order. I think we're good. That should be good. And then I guess it is time to start soldering. Ah!